or Junjun Inglesero. Welcome back. Okay. Hello world. Hello parts of the world. So let's go back to this topic. This is reaction kinetics, initial rate method. Right? Who loves this topic? Who loves this topic, by the way, class? Okay, so before anything else, we need to discuss the basic for this, right? So for example, okay, so if we have this reaction, say, A plus B plus C plus D, right? So to match A plus B plus C plus D is equal to the product. Okay. So if you try to relate this with reaction mechanism, this is going to be a tetramolecular chemical reaction, right? Because there are 4 reactants. 1, 2, 3, 4. Tetramolecular. Okay, it's more than 3. It looks like very strange because most of the chemical reactions will only yield up 3 or like that. So this is only for the purpose of discussion, hypothetical chemical reaction, right? Okay. Any questions so far for this? We go to maximum, right? So if you say we need to compute for the rate law, it's gonna be R is equals to the rate constant, the concentration of A, okay, things like that. Example only, and then it's gonna be a rate, let's say X, concentration of B, raised to the power Y, let's say C, raised to the power, let's say anything you will, anything letters, any letters, Q, then concentration of D raised to the power L. Okay, get the point? In this initial rate method, guys, no, the coefficient of your reactants will not be the exponent. Okay, this is the first thing to analyze. This is not the same with reaction mechanism, that your coefficient will be your exponent. Okay, that's very clear. Okay, things like, so it's gonna be X, Y, Q, L. So this will be your individual reaction order of, with respect to A, with respect to B, with respect to C, with respect to D. So your overall reaction order will be X plus Y plus Q plus L. Okay? Then it will be more simplified. Let's say you have only 3 reactants, up to Q only, like that. Okay, but this X, Y, Q, and L will be numbers. Okay? Because we are not yet sure what particular order is that. That's why we need to designate letters. Okay? Things like that. Any questions so far? Not yet, right? No question. Okay? So for example, if I will have the, okay, the reaction of, let's say only example only, right? Okay, so A plus B is equal to C plus D. This is just like hypothetical examples. So we have, so D A over DT, right? See, negative. Why negative? Because during the chemical reaction, your reactant will become less and your product will become higher. Okay, that's why negative. Okay. Equal to negative dB dt, like that, no? Negative pa rin siya. Okay, then you have equal to, or let's say negative dc, no, positive na siya because it's product, dc dt, and then dd dt. Okay, so this is the real rate, what we mean, this time in the denominator. Okay, the change of concentration with respect to time. Okay, the delta change in concentration with respect to time. That's rate law or rate expression. Okay, see, time will be in the denominator, but we don't deal with this dAdt, dBdt. To make it simpler, let's just put R or the rate. You get the point? But this is really the reality. Okay, get the point. Ganon. Okay. Okay, then most of the reactions have only two reactants, right? So we normally express our rate law here in the topic of initial rate method as like this. Okay, R, K, X. Okay, let's say X, let's say Y, and then let's say B, let's say Q, like that. Okay. With the point, but to make it more simpler because these are all letters, let's try to say this in this manner. Let's just put K, concentration of A, raised to the power X, concentration of B, raised to the power concentration Y. Too much variables, right? This is what make it confusing, right? Okay, but don't be bothered with this because this is still hypothetical, right? As long as we know X and Y are reaction order. Okay, reaction order, individual reaction order with respect to A, X. Reaction order with respect to B, Y. So overall reaction order, X plus Y. Okay, we remain of order, that is exponent, huh? Exponent. Okay. But here is not the coefficient. Okay, we have already the chemical reactions. Okay, don't be confused that one. Okay, now let's go to the problem. Okay, get the point. So, in a chemical reaction of what do you call this one? Nitrogen oxide or nitric oxide. Ganun ba yun? Okay, plus chlorine gas. So we don't know yet the products also. We don't know yet. So this is the problem. We need to print the product. So in this case, let's say A plus B is equals to AB. So therefore, this is NOCl2. Okay, nitrooxychloride, right? Then balance the chemical reaction, 2 nitrogen, chlorine, like that, no? So we need to put here 2. Okay? So, balance or not? Okay. Balance, right? Okay. 2 nitrogen, oxygen 2, chlorine gas 2. Oh, diba? Okay. Your technique in your product, guys, if there is a subscript, it will become on the coefficient, ha? On the compound. That's the technique. Okay, you don't have also to put that in the Cl2 because it looks like perfection. It's like NO plus Cl2 is equals to NOCl2. So when you balance the chemical reaction, perfection, right? But it's not the way it is used to be. Okay, you need to put the subscript beside the coefficient. Okay, things like that. Just like saying Cl2 is equals to 2 chloride. Like this, no? See. The subscript will become in the coefficient. Okay? Get a point. The same story. Diba? Okay. Now, we have trials. We have an experiment of our concentrations of NO, chlorine gas, like that, and our corresponding initial rates, right? Okay, we have trial 1, trial 2, trial 3. And now in our NO, trial 1.1, trial 2.1 also, and trial 3.2. And then in our chlorine gas, trial 1.1, trial 2.2, trial 3.2. And then in our initial rate, trial 1.18, trial 2.36, and trial 3.1.34. The questions is gonna be like, what is the reaction order? Okay. I will write, right? So, what is the reaction order? Okay. So, what is the... So, just listen, guys, because it's very difficult to write in a very, small whiteboard. Okay? So, we say, what is the reaction order of NO with and reaction order of chlorine gas, and also the overall reaction order. Okay, things like that. So in this case, we need to say rate low is equals to K concentration of O times the concentration of chlorine gas X and Y. So there are unknowns in the exponents X and Y. So in here, it looks like very complicated, right? Because the exponents are X and Y, but don't be bothered on that, okay? Things like that. Okay, now, so you need to determine, so the first technique is you need to determine what's being changed or not in your trials. Let's say, for example, Junjun conducted an experiment and analysis in the laboratory, okay, microscaling laboratory. Then my concentration of NO doesn't change after my second trial. Okay, so you don't need to focus on this if there's no changes. Okay, go to the trial that has changes, right? It could be either 2 and 3 and also 1 and 3. These are the two possibilities. Okay? Because if you try 1 and 2, there's no changes. Go to the changes. Okay, now, if you look at 1 and 3, you need also to consider the initial rate 1 and 3. If you consider 1 and 2 like that, no? For example, 1 and 2 also is initial rate consideration. Okay? You get the point? Ganon. If 2 and 3, 2 also, the 3 also of the initial rates you will consider. Okay, now let's try here for NO first. Okay, NO. So for NO, let's say the changes are, okay, 0.1 to 0.2, the 1 and 3. So from 0.1 to 0.2, your concentration is multiplied by 2, right? So 0.1 times 2, mga palagingging. Okay. 0.1 times 2. I teach you the first method how to do it. Okay. So 0.1 times 2 like that. Okay. It's gonna 0.2. So if you times this initial concentration 2, the answer will be 0.2. That's why times 2. You get the point? So 1 and 3 times 2 like that. Okay. You get the point? So you need to say your concentration of NO multiplied by 2, right? Okay, now we are here in the NO, right? Or less, it will not reach maximum of 3 in this kind of topics, or generally in initial rate methods of reaction kinetics or chemical kinetics, right? Okay, now let's use this NOx. So if this is multiplied by 2 to yield 2, then your concentration will be, let's try first the 1 order, first order, so let's say NO, first order. So you need to put 1 na in the exponent, so NO1. So your rate also will be increased in a factor of what? Since it times 2, so 2 raised to the power 1 is equals to 2. So your initial rate will increase in a factor of 2. So which here? 0.36, 0.1344. Now since you use 1, take a look with the 0.18. Since you use 3, take the rate 1.4. Okay? So this is increasing the factor of 2. So 0.18 times 2. Okay? Because the answer is 2. So let's try to increase with a factor of 2. Okay? So 0.18 times 2. 0.36. This is not 0.36. This is 0.144. So this is not the way. So wrong. Okay? Meaning to say, you will use the second order. For example, okay, so NO raised to the power 2, okay, like that. So again times 2, so 2 raised to the power 2 is equals to 4. So you will increase by a factor of 4 your initial rate, again 1 and 3. Is this correct? It will become 1.44, so 0.18 times 4. No, it will 0.72. So it's not 1 and 3. Okay? So you need to go to another trial. So you need to go to 2 and 3. Okay, so 2 and 3, if you multiply our initial rate, 0.1 times 2 equals 2.2. This is correct. How about your initial rate, this one, 0.36 times 1.44. Okay, consider this one, no? So 2 and 3 trials. Okay, with respect to NO. See, if you multiply them. So concentration of NO, like that, right? Multiply by 2, like that. Okay, then copy this because we are all still in NO. So NO raised to the power X. So this is the order. We try first order first. Okay, NO raised to the power 1. So what will be your increase factor of your initial rate? So let's say R. Ganon. Now, so 2 raised to the power 1. 2. Okay, so your rate will be equal to 2. So, is this true that you use 2 and 3, your concentration will be increased by 2 in this one? So, 0.36 times 2. Okay. No, it's not. It's still 0.72. You got the point for NOs. So, it's not first order. Let's try NO second order. Okay. 2 raised to the power 2 is equals to 4. Okay, so is this true that we need to increase a factor of 4 from your trial 2 and 3 in your initial rate? So let's say 0.36 times 4. So 0.36 times 4. So it's 1.44, right? So meaning to say, you need to multiply by 2 to have a factor of 4 in your initial rate. So therefore, we are considering the second order. Okay, with respect to NO. Got the point? So put now here the 2 at the top of NO as your exponent. Like that. Okay, then, okay, get the point? Now we go to the chlorine gas. The same story. Okay, in chlorine gas, what is changing? Let's say we have 1 and 3, right? Okay. And then 2 and 3 are constant, so you don't have to consider that one. 1 and 3 and also, 1 and 3, right? First, no? Okay, then 1 and 2. Okay, things like that. Okay, chlorine, right? Chlorine gas raised to the power Y. Ganon. Okay, chlorine gas raised to the power Y. Okay, now, go to your concentration. If you multiply your concentration, let's try first 1 and 3. This one. Okay. If you multiply by 2, it will become 0.2. Charot. Okay, times. Yes. Okay, multiply by 2. Okay, now we have first order first. Okay. Cl2 raised to the power 1 is equals to your factor initial rate. So therefore, 2 to the power 1 is equals to 2. Okay, so is this correct? 1 and 3. You need to increase a factor of 2 to come up with 1.44. Okay, so again, so 0.18 times 2. Ganon. So it's not because 8.36. Okay, it's not 1 and 3. So how about 1 and 2? Okay, things like that. Okay, how about 1 and 2? The 1 and 2. So, okay, 1 and 2, this 1 and this 1. Okay, consider that one. Okay, now 1 and 2. So, we have 0.1 and 0.2. So, times 2 will be 0.2. Yeah. Okay, times 2. So, you need to times your concentration of chlorine gas. So, chlorine gas times 2 concentration. Now, therefore, we will use first the first order. Okay, so chlorine gas raised to the power 1 is equals to, okay, R. Then your chlorine gas times 2, then you have 2 raised to the power 1 is equals to 2. So we need 2 factors. So let's say 1 and 2 na. Okay, so increase by a factor of 2 so that it will become 0.36. So try it. Okay, 0.18 times 2 is equals to 30. Yes, 0.36. So meaning to say, first order your chlorine gas. So put 1 here. Like that. Okay, it will now become your rate law. So your rate law or rate expression will be R is equals to rate constant of NO raised to the power 2 and then chlorine gas raised to the power 1, like that. So your individual reaction order with respect to NO is 2 and your reaction with respect to chlorine gas is 1. The total overall reaction order will be 3. Now, second question, what is your rate constant? Charis, okay? What is your rate constant for this? So compute this one by math. You can easily get what is the value of your rate constant by manipulating the equation. So we have, so how can we manipulate this equation? If you try to solve K, let's go back for the basic in algebra. If you want to solve for K, what are you trying to do now here? Okay, so you need to divide both sides by this. Okay, NO, like that, no? To chlorine gas 1, and also here the R, NO to chlorine to gas, so cancels. So this is now the value of your R. Or you can say cross multiplication. There are two methods how to do it. Cross multiplication method and also dividing both sides with the partner of the rate constant so that it will be cancelled. But for me, I always use before cross multiplication. It's very easy to manipulate, right? But if you want like this also, you can also do this. Some also students like this, especially algebra. 2x is equals to 3y plus 2, like that. Solve for the value of x. And you have to ganon, okay? You know what I mean? Because it's too long story if I have to explain everything. You get the point? Things like that, okay? So, if my students now are taking BS Math, okay, and BS Chemistry, BS Physics, or BS Chemical Engineering, so it's easy for them to relate, okay? I don't think so with other courses. Okay, get the point? But it's okay, okay. So this one, no? So K is equal to the rate law. The rate law meaning the rate of chemical reaction. That's what it means. Okay, N O raised to the power 2 mga palagingging, then chlorine gas raised to the power 1. O, diba? Now, how can you compute for that, the rate? Now, go back to the title, initial rate method. Of your trials, 1, 2, and 3, which is initial? Of course, the trial 1. Use the initial rate 0.18 in your numerator. This is also sometimes the, what do you call this one? The confusing part, because some students will divide this 3, 0.18 plus 0.36 plus 1.44 divided by 3. It's not like that because the English tells initial. It's not average. Okay? You get the point? It's matter of English. Okay, initial rate. So your R, because we have 3 R's here, right? So actually we can use this one, any. But you know the adjective is initial. If the adjective is final, then we use 1.44. Okay? And then if the adjective is average, then we need to divide the 3. Right? If the adjective will be the total, you need to add the 3. Right? So, here the understanding of interpretation of English language would matter a lot, ha? Okay, so initial rate will be 0.18. Ay mo pagbuhat-buhat ninyo mga i-divide by 3 mo, iimbutan nyo sa R, i-total ninyo mo na ang R, i-final mo kami put, because the word is initial man siya, so we need to put 0.18 because this is the rate at initial trial. Okay? So 0.18. Okay. You need to use now the concentration in your first trial because this topic is initial rate method. Okay, meaning initial, okay, not final. Okay, things like that, no? So our NO will be, because actually there are three concentration kasi. Okay, that's the point. But only one is initial, the starting point. Okay, so point 1 times 2, see? NO, point 1. Okay, chlorine gas also is point 1. Okay, so point 1 raised to the power 1 is still point 1, no? Okay, things like it. So point 1 times point 1 is equals to like this. Okay, times point 1 is equals to, okay, 1 times 10 to the negative 3, charot. Okay, 1 times 10 to the negative 3, 0.18, like that. And then 0.18 divided by, charesh, uh, uh, 3, mga palaging, 180. Okay, so this one is the same as saying, 0.001. 1, 2, 3. Move your zeros to the right, and you have to put negative because this is point something. If point something, you move to the right and the exponent will be negative. But if not point something, you move to the left and your exponent is positive. That is basic rule in math. Okay? So, nakakaloka. 0.18 divided by 0.001, so 180. So, since in rate constant, guys, in chemistry, we always have exponent in putting in our answer. So 180 is just telling us 1, 2. So 1.8 raised times 10 to the 2. But actually, some teachers will consider the 180, but it, you know, it will be in exponential form. But actually, it's just the same. Okay, you got that point? So 1.8 times 10 to the 2. The unit is your headache. Okay? What is your unit for this? Remember, there's no mentioning the units here. Hala. Okay? There's no mentioning of the units here. Then if you add the overall reaction order, this is 3. Okay? So, in our standards of the units of our chemical kinetics from 0 order, first order, second order, it's up to second order. So, we need to manipulate this by using another equation so that we can determine the, what you will try to determine, units of our K. Okay? In the rate, so, we don't know. Okay, you got the point? To the unit of the rate. See, it's not mentioned kasi, oh. You get the point? So this is the, sometimes the headache. The initial rate don't have specific unit. Really, it's up to you what unit you'll be able to use. Okay? Let's try to use the standard formula of rate constant, which is, memorize this all throughout your career. Charot! Okay? In your 5 years of engineering, okay, or in specifically chemical engineering or BS chemistry. Okay, things like that. So we have here, so K is equals to the capital M raised to the power 1 minus N to the negative 1. Why we use this? Because we are having a third order which is far from 0, 1, and 2. Okay, so substitute values. Okay, is equals to capital N, 1 minus the overall reaction order, this N is 3, right? And then T here could either be second, minutes, like that, because it's not mentioned. But the standard is always seconds if it is not mentioned or unless otherwise specified. So second will be the automatic unit of your time, so S negative 1. How about your capital M molarity or molar? Okay, let's say it will become K is equals to capital M negative 2 S negative 1. Actually, this is correct already. Your unit will be, okay, 1.8 times 10 to 2 molar negative 2 S negative 1. But in different examinations in the future, sometimes they will try to break this molar into moles per liter. Okay? So that's why when you compute this and you can find this, you cannot find this unit. Okay? How can you do that? So you need to break this to moles per liter. Okay, let's say moles per liter. Again, basic math. Raised to the power negative 2. Then S negative 1. Like, okay, this is gonna the same as saying 1 over mole, okay, per liter raised to the power 2. S negative 1. So this is gonna be small mole squared chart. Okay. Letter times letter, letter squared. Okay. And then S negative 1. Now in math again, if you have like this, okay, how can you attack that kind of fraction? Since you know this the small raised to the power 2 and letters, but it's one component, you cannot isolate that. Okay, treat that as one. Okay, so in math you will be able to do that in this way. Okay, like that, no? Okay, you take 1 over 1. In math, 1 will be 1 over 1 in dealing with fraction. Because you cannot manipulate if you will never say 1 over 1. You get the point? So, 1 over 1 times this one component, mole squared over a letter squared. This will reverse the rule in mathematics. So, it will become letter squared over mole squared. Okay, letter squared, mole squared. And then retain the S negative. It will never be affected, chuvas. Okay? Nakakaloka. Negative 1. Okay. Now it will become 1 times letter squared, letter squared. 1 times mole squared, mole squared. Okay? And then S negative 1. Like that. Okay? So this is gonna be things like this. Okay? Ganon. Okay. This is also okay. Then it will be okay also. Letter squared, mole raised to the power negative 2. Actually, there's a lot of modification. Or letter squared, mole to the negative 2, S negative 1. Or letter squared, mole squared, 1 over second. Because S negative 1 over second. You get the point? Clever in the unit of measurement. Meaning, there's a lot of variations how to carry the unit. Okay. There's no issue in multiple choice. Okay, but how you make that final unit. Maybe you will be wrong somewhere along the way. Okay, with the point. Things like that. Okay, so it looks like very complicated really in real kinetics. In kinetics, chemical reaction engineering, the units of our rate, low rate constant, it looks like very confusing. Okay, you cannot do direct if you don't memorize comprehensively. With the point. This one, k is equals to m1 minus n t negative 1. If you will not memorize that, you cannot answer if the overall reaction order is beyond 3. Okay? You get the point? Ganon. Things like that. If you really, if it's mentioned here the unit of your initial rate, it doesn't mention, right? Because if you mention also, okay, it's very easy to detect the exponent of your concentration of NO and Cl2 because we can determine the order through the units also. Maro, di ba? That's why the problem doesn't state the unit of your initial rate because the moment you will show the initial rate, 1 over second, like that, let's say 1 molar like this second, so it will become first order. No, so no need to compute because it's already noted by your initial rate, right? Okay, things like that. Okay. So that's why we don't give the initial rate unit of measurement. Okay, but take note. Okay, yeah, it's gonna be like that because it's not mentioned the NOCl. So it could be really the initial rate is basing in your reactant. Okay, so it defeats the purpose if you will give the unit of your initial rate immediately. Okay, so because it will be easy to detect if it is first order, second order. No need to like this, like, okay, get the point? Now, guys, no, if you use another method, that's the first method, no? Through analysis, like that, this one. multiply by 2, this one, if the concentration will be multiplied by 2, then your initial weight will be increased by a factor of 4, blah, 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 so and so. Now we have another method, which is your favorite, I think so. This is the ratio and proportion. The ratio and proportion is sure ball. You don't have to think, wait, if this will be times 2, it will become 4. No need to think like that anyway, okay? Try to follow the ratio and proportion kalas. No need headache. What will I increase after second trial, third trial? No need to think like that, okay? Ratio and proportion is simply gathering the initial state and final state. For example, this one, okay? Okay, this one, no? So 0.1 and 0.2, right? So 1 and 3, okay. Now, 0.18, like this, okay? So you need to do the ratio and proportion for that because it changes, okay? You get the point? Now, you can also have the 2 and 3, okay? Things like that, okay? You solve, let's say, for example, okay, mga palangga, so you will say, okay, so 0.1 over 0.2, because you take 2 and 3, the ratio between 2 and 3, the relationship between trial 2 and trial 3. So your concentration of NO will be in trial 2.1, so 0.1, trial 3, 0.2. Now, your initial rate also will be considering 2 and 3, of course. Then, if you try first the first order, you need to put the exponent to 1. Okay, so meaning x, so that you can determine the x, the order. Here, you need to determine the order by x and y unknowns. Okay, you get the point? If you don't want sikot, then use the other one, the increase the factor, blah, 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 so and so. Hilig mo tamban-tamban, anto ka sa pikas ha, sa first method. Estimate, bana-bana. So, you need to use the first method. Second method is very formal, okay, very standard, using the equation by ratio and proportion, or the formula. Okay, then 0.36, 0.36 over 1.44, the value of x. Now, it looks like confusing because the x is the exponent. How can you compute the value of x if it is an exponent in algebra? Again, get the point? How can you do that? Use the logarithm method. Okay. So first, divide this first. 0.1 divided by 0.2. 0.1 divided by 0.1 divided by 0.2. So ganito, if the exponent of the unknowns will be atop the variable, okay, say x, y, f, like that in a fraction, then you can use the logarithm. Things like that. So this is 0.5. See? 0.5 raised to the power x. Kakaloka. Okay, because normally the exponent is numbers, right? Okay, then 0.36 divided by 1.44, no? So we have 0.25. Wala. Guys, take a look. So, if this number is the same, say 0.5 and 0.5, it's very easy. You need to cancel, then the exponent here is understood to be 1, so x is equal to 1. But this is not the same base number. So all you have to do is logarithm talaga siya. Okay? So x is equals to the logarithm of 0.25 over the logarithm of 0.5. Now this is the issue also. Why? We have the same logarithm at the top and logarithm at the bottom. Now, in math, if the same, we need to cancel, right? So, most of the students will cancel the log because the same letters. But take note, the number is part of the package. So, meaning to say, you cannot cancel the log unless the numbers also from numerator is the same and the denominator. Okay? So, the other students, including me, I will cancel the log because I can easily divide the 0.25 and 0.5. Okay? But it's not like that. Okay? You need to carry this log. Okay? Things like, you cannot cancel. Okay? Cancel only if all are the same. Say, log 0.2 over log 0.2. Okay? You get the point? The total package, huh? Get the point, things like that. So you do this individually. Okay, now, this is the drawback. Your example in your sample problem, the teacher will use a number also that when you cancel the log, it will be the same also as individually using the logarithm. You get the point? That's why other students will cancel immediately because during the sample problem, it happens that the answer also will be 2, 1. That's why they interpret. That's why I told you, science is not mechanics. It's not pattern. It's not sequencing. It's not patterning because of the first problem. You need also to pattern that in the second, in the third. It's not like that, okay? We need to go by the rules. Okay? It's not a logic question like in Facebook that you need to the gap in the first, the second gap, the third gap. It's not like that. This is not a logic question. This is, by rules. Okay? Science rules, math rules. Okay? You get the point? Math rules, madadala pa siya. Because pattern, sequence, like the progression. Progression or factorial. Okay? But in chemistry, you cannot do that all the time. You get the point? There's specific rule to follow. That's the point. Like that. So individually doing that. Okay. Logarithm of 0.25 pila siya mga palagingging. Okay, x equals to 0.621 negative. Okay, logarithm 0.5 mga palagingging negative 0.3010. So divide, cancel the negative x is equals to, so 0.60 divided by, okay, 0.60, 0.21, okay, divided by 0.3010. So your answer will be 2. See? 2. So your x is 2. Meaning to say your order of your NO will be exponent 2 in your rate law. So R, K, NO raised to the power 2. So the same as what we did in the first method. The same answer. If you want this, it's okay. If you want also the other one, it's okay. Okay? It's up to you what to use. Because this one is lengthy. Lengthy, but it looks like more short. Okay? Rather than the first method na medyo like estimating, approximating, that if I will multiply by 2, what will be, I will be increased by like this. And this is the usual method that our teachers in chemistry using. The first method is not this ratio and proportion. Okay, the drawback is, in our school, our teachers only using one method. They will never give you the another method in doing the thing. Okay? So it's sariling sikap how to do the other thing. You can go by the books, you can research, or you can refer to your friend who is, let's say, very brilliant in math. Just like me before, I have a friend which is very smart, magna cum laude, things like that, always top in the every level. Then I must talk to him because he's very good. He is 2 years older than me. He is third year, like that. So our gaps are not too far. That's why we can always communicate with him, ask him, and any classmates, we refer also to him. He will teach. At the time, he's not yet a teacher. By the time he is graduated already, he is now a teacher, like that, and we still under him because 2 years gap, right? So fifth year, we are still third year. When he become a licensed chemical engineer, he teach immediately. You get the point? So by the time we are still on the fifth year college, he is also our teacher. You get the point? Things like that. So it's very good because our age high, and then we can normally talk to him because the older teachers and the older instructors, it's not easy to approach. Get the point? They are very mature, and they're, unlike the age gap is very near, so it looks like very active. You know what I mean? If you are in the same range of age, you can really easily talk, communicate. But if, for example, I am 25 and then the instructor is 60 years old, how can we easily talk to that kind of teacher that's very old? It's not the same level youth. or young. You get the point? You cannot, though it's also approachable, maybe, but the way the gap is not really, you know what I mean? It's not really approachable in first impression. That's why you'll never attempt to communicate. Of course, okay, you got the point? Nakakalaw. But this older than you a little bit, 2 years, 3 years, it's easy. Okay, because not married yet, single, like that. Okay, rather than talking with this instructor 60 years old, 70 years old, you will think you will never be, right? But actually, maybe you will never spend your time to share with you by just only silly, not silly questions, only basic questions you ask. You get the point? Even though difficult, it's not approachable. They're approachable for other topic like personal thing like that during class they were very because the class they can ask. Then why you keep on reading, asking? It's also okay after the class or within the class, but during the other time, they will never entertain, right? Diba? Okay? It's impossible you will entertain you. But not all, but majority will never entertain you, right? Because of the age gap. Okay, things like that, no? Okay, but in our time, Engineer Stephen really is very brilliant. He is approachable. I really learned some of the techniques from him, like that, okay? From solving, because I really need to communicate like that. And the books also. Books, teachers, and him. And also sariling sikap. But dagan din siya ang sariling sikap because not all the time, sariling sikap in your own effort and hard work to learn. It's not from the teachers. It's not from your friend. Yourself. To really understand what's going on. Because you cannot ask them all the time. It will disturb their time, right? If you ask always assistant, then you have to give them snacks or there's what do you call this one? There's exchange on the effort you give to them. Okay, so Stephen doesn't require any snacks just to help you. Okay, but you will never do that all the time, right? Because it also ate in his time. Get the point? Things like that. You know what the point? So things like this is very easy to manipulate if you know the method. Okay? Things like that. Okay, mga palagingging. Okay. The only difficulty here is you don't know the chemical, you don't know the product yet. And you don't know really the whole equation. Okay. Any questions so far for that, no? Wala na tayong mga question, mga kapatid. For that, okay, nakakaloka. Okay, wala na, no? Okay, thank you so much for watching, guys. I hope you like the video and you can share to anybody else. Bye-bye, God bless everybody. See you later.